Okay, so welcome back guys. So in this video, as you can see, we'll just cover the following topics. So really we should have probably covered constants in the last video, since we were talking about variables. I think variables, constants, they go together. However, I guess I just forgot to do that. Alright, so we'll just cover this quickly. Right, then we'll talk about different operators, so arithmetic operators. These are just mathematical operators, so yeah, plus, minus, multiply, divide. Right, so exponentiation, so powers, and then possibly these which people might not be familiar with, right? So div is integer division, and then mod, this is going to be the modulus or remainder. Then we've got comparison operators, okay, logical operators, and then finally just selection, so looking at if and case. Alright, so I think like last time, let's just clear this. Like last time, let's just jump in. So I'll make this a little bigger. Right, so first if we look at constants, let's go constant and let's call it pi. I'm just going to copy this. So yeah, this is the value of pi to sort of, 15 decimal places or something. Of course then we can just output, right, just to check it's working. So here we see this is working. Now the one thing to note is actually, I think for A level, they use this one. So they use the equal sign to kind of assign a value to a constant. Alright, whereas I think for IG, they actually use, this kind of pseudocode assignment arrow. In my examples, I'm just going to use the equals. However, it will actually work if you use both. Let's just change this just so we can see it changes. Okay. So, the website will let you use both. However, really, I think, if you're doing A level, they would prefer if you use equals for constants. And then if you have a variable, like let's just say x, right, integer. Right, if I can type. So for variables, they would want you to use the assignment arrow, alright, and then for constants, just use the equals. Alright, so, for constants, I think that's basically finished. I suppose, if you don't know, the reason it's called a constant is because, we can't change it. So once we've given it this initial value, right, we're not allowed to update it. So let's just say if we do, so let's say pi, and I don't know, we just say 999. Right, okay, here it gives us this kind of cryptic error. To be honest, I'll probably improve this at some point. I think before it did give a nice error, but yeah, I'll have to get around to to improving that. Basically, again, the key feature is if it's a constant, right, we're not allowed to assign a new value to it. Which of course is good for something like pi, right, because pi is not going to change. So, right, if we just go on to the arithmetic operators, so maybe let's just declare two variables. Or in fact, we could just output them directly. So let's just go, for example, 1 plus 2, right, not nice and simple. Let's also go for 1 minus 2. These should be pretty simple. Right, let's try maybe 3 multiplied by 4. Right, then let's try divide, maybe, 10 divided by 3. Alright, so I'm just going to sort of start with those simple ones first. So of course, 1 plus 2, alright, 1 minus 2, this is all working. Now the thing to note is that of course if we're dividing, here this is going to result in a kind of real number. It's not going to be an integer. So obviously if we did 9, 9 is going to be 3. So let's say if we were kind of doing this and then assigning it to an integer, this would work. But if we did 10 divided by 3 and tried to assign that to an integer, then it's going to give us an error, alright? Because as we see, this is not an integer, it's not a whole number. Okay, so now if we go on to exponentiation or powers, so for example we can try something simple. Let's try 2 to the power of 3. And note the power operator, right, the exponentiation operator, it's going to be the double asterisk like this. So if we just run this, 2 to the power of 3, right, that's going to be 8. Of course we can try like 2 to the power of 10. Which, if you know, I mean, this should be 1024. Yeah, okay, 1024. Because right, this is going to be 1 kibibyte. And then yeah, I mean, if you remember from the book, right, so 2 to the power of 20, that's going to be 1 megabyte. Yeah, and then of course, you know, you can go 2 to the power of 30, 2 to the power of 40. Now let's try, let's say we want to do something different. Let's say we want to do 16, but we want to get the square root of 16. Now, if you remember in maths, I mean, we can write the square root as like to the power of -2. So yeah, 16 to the power of -2. That's the same as actually doing this. So if we do this, this should return 4. Yeah, okay. And then for example, let's say we have 81 and we want to get the kind of quad root. So yeah, if you know this, right, this should return 3. Yeah, because we say, well, 3 squared is 9, 3 cubed is 27, and I guess 3 to the power of 4 is going to be 81. So now looking at div, right, this is going to be integer division. So let's say we try something like maybe 9 div, let's say 5. So what this will do is, well, this will do the division, right, but then it will only get the integer part of this. So I mean, let's just see what 9 divided by 5 is. I guess that's going to be 1.8 maybe. Okay, right, 1.8. So if we just do div, well, we can see this is just going to be 1, right? It's only going to get the integer part of this. So yeah, you say kind of it's going to have like no remainder, right? And yeah, no decimal part. So just to make sure you understand this, let's say we say I don't know, maybe 17. So let's try 17 div 3. Well, 3 can go into 15, so that's going to be 5 times. I mean, then there's, you know, 2 remainder, but yeah, we just ignore that. So here, this is going to be 5, because this would be, you know, sort of 5 and 2/3. And yeah, so here we can see it's 5. So I would say if you don't understand this, you know, just have a little play around with it. I mean, let's try one more. Let's try maybe like 28, and let's try divided by 12. So if we think, well, here, right, 12 is going to go into 28 2 times, because we can go, right, 12, then 24. But, you know, then there's not enough remaining, right? There's only 4 remaining. So yeah, this is going to be, yeah, this is just going to be 2. So, I mean, one that's kind of related to this, let's say 28 and let's say mod 12. So mod, this is going to be the remainder. So if we divide 28 by 12, well, we can divide it 2 times. So, you know, that's going to be 24. But, you know, then we have 4 remaining, right? So 4 remaining, we can't divide it again. There's not enough. So yeah, we're just going to be left with 4. And then, yeah, we see here, right, this is the remainder. So, I mean, I think one way I've seen this explained well is that you can, you know, think about pizza. So if you've got, say, 10 slices of pizza and you've got, let's say, 3 people, well, in that case, so let's just try this. So 10 slices of pizza, right, divided by 3, and right, 10 slices of pizza, mod 3. So here, 10 divided by 3, well, this will be how many pieces of pizza each individual person gets, right? So this will be 3, because, yeah, I mean, each person can get, you know, 3 bits of pizza. Now if we try, well, 10 mod 3, this is how many bits of pizza are going to be remaining. And if we think, well, you know, we can get up to 9, because, you know, well, 3, 6, 9, right, then there's going to be 1 bit of pizza remaining. So that's going to be what this mod 3 is going to be. And yeah, here we see, right, so each person gets 3 bits of pizza, and then there's 1 bit of pizza remaining. I mean, so hopefully that makes sense. You know, if it doesn't, again, just, you know, probably play around with these. But yeah, I mean, like, probably people are familiar with these from maths. I mean, hopefully. Right, I mean, so if we look at the next one, I mean, these are pretty easy. So let's try, let's go output, and we'll just go 1 equals 2. So, right, this is going to output false, because, well, here we're asking, is 1 equal to 2? And I mean, yeah, in this case, well, this is going to be false. Now, of course, if we try is 1 equal to 1, right, that's going to be true. Now, let's say we want to do not equal. So let's go 1 is not equal to 2. So yeah, not equal is going to be what, the less than, and then the greater than sign like this. So here this is going to be true. Yeah, because they're not equal. Of course, if we have 2 not equal to 2, well, this is going to be false. Now, we can also do this with, say, strings. So let's say ABC, and we'll see. Okay, there we go. Let's say is ABC. Yeah, all right. Okay, well, first let's try equal. So do people think this will be true? So yeah, just have a think about this. So is, small ABC equal to big ABC? So, right, here it's saying false. And the reason for this is, again, think about the ASCII code. So this is, 97, 98, 99. All right, and then, yeah, 65, 66, 67. So, when it's comparing them, it's going to be checking the ASCII code, right, making sure they're all even. So here we can check, well, not equal. So yeah, small ABC not equal to big ABC, right, this is going to be true. Now, all right, let's try greater than. So let's go, for example, 4 is greater than 2, well, that's going to be true. Right, let's try greater than or equal to. So let's say 4 is greater than or equal to 4. Right, of course, here this is going to be true. Whereas if we try this one, is 4 greater than 4? Well, this is going to be false. Yeah, so, I think those are hopefully quite simple. Let's just copy that. Right, let's try here. So what is 4 less than 4? Right, that's also going to be false. And then here, let's go, what is 4 less than or equal to 4? Right, that's going to be true. Right, so yeah, I guess for the comparisons, right, so the thing to note is that, here we've just done these comparisons, mostly using integers, but of course we can also use, we can also use the different primitives. So if you remember before, we saw real numbers. So let's try, for example, yeah, all right, let's go back to having this pi again, and then I'll just copy this. So we can say maybe, yeah, like is pi greater than 4? Or, let's actually switch this. Yeah, all right, let's have 4. So is 4 greater than pi? All right, and then, well, let's just run that. And then here, that's going to be, okay, no, that's going to be number 4. No, sorry. Okay, right, yeah, that's going to be number 3. All right, this one. So we can see this is true because, well, 4 is bigger than pi. Now we can also use, for example, variables or, yeah, well, let's say variables. So let's declare maybe a boolean. So let's say maybe did homework. Right, so this is going to be a boolean, and let's say did homework is going to be true. So here we can check. Let's say did homework equals true. Now here this output, it's not, yeah, probably not very useful. But in a minute, when we start looking at if statements and sort of case, yeah, this is going to be more useful, checking these conditions. So yeah, here it just says, and in fact, let me just comment these because it's a bit confusing. So yeah, here, well, we assign true to did homework, right? Therefore we check, well, this did homework is going to be true, therefore this evaluates to be true equals true, which is just going to be true. Now if this is false, well here, right, this did homework is now false. So now we've got false equals true, which is going to be false. Yeah, so hopefully that makes sense. And I suppose, right, something else that we can do, we can also use this for strings and characters. So let's try, for example, A, and let's see if A is bigger than B. So before I run this, just think, right, so what do you think this is going to output, right? Is this going to be true? Is it going to be false? And yeah, try to think of a reason. Right, so yeah, let's just run. Okay, so we see, right, it says false. Now the reason for this, again, right, this is the ASCII code. So this A, this is going to be 65. So here it's saying, well, is 65 bigger than 66? right? And then of course, well, yeah, this is not going to be true. I mean, yeah, if we try like ABC, I mean, let's try, I don't know, BAC or something. And yeah, that's still going to be false, because I guess here, again, it's just going character by character. So I think, yeah, I think for the comparison operators, right, that's all of them. So I guess now we can just look at the logical operators. Right, so I'm just going to delete these. So here, let's just output, let's go maybe 2 is greater than 1, right, so this is going to be true. And then let's say and, maybe, yeah, 3 is less than 4. So in this case, well, 2 is greater than 1, this is true. Then when we say and, well, this means both of them have to be true in order for the kind of whole expression to be true. So here we say, well, 3 is less than 4, right, this is also true. So yeah, this output's true. Now, of course, if we change one of these, let's say 4 is less than 4, well, this is going to be false. So now we've got, well, true and false, which is going to evaluate to false. And yeah, we can see. Now, of course, if we make this less than or equal to, right, now it's going to become true again. So, okay, and then, yeah, so then we can look at or. So let's just say or, in fact, hang on. Right, let's change it back to this. Okay, so here it's going to be false. Right, now if we make this or, well, for or, you know, only one of them has to be true. So if we have true or false, right, then this would then evaluate to true. Yeah, which we can see here. Right, so if we look at the final one, the not, let's just go here, let's go output true. Well, of course, right, this is going to output true. Now if we go not, well, this will just invert it. So yeah, well, not true will now become false. Now the thing to note with this, let's say we go, yeah, or false like this. So, you know, a common mistake is people might think, oh, this will say true or false. Which, I mean, I guess what, so that this would be true. And then they think it would do, well, not, you know, of this expression. But actually the way it's going to execute is going to be this. So it's going to do not of true, right? Because, yeah, this not has a higher precedence. And, right, then, yeah, once it's then done this not of true, then it's going to do the or false. So, I mean, effectively it's doing this, really. Yeah, it's doing this first, right, then or false. Now, of course, if we want it to do this, right, so here true or false, this is going to be true, so this should output false. Right, whereas if we remove the brackets, well, not true, this is going to become false, right, then it's going to be false or false. So, I mean, yeah, that should also be false, actually. Yeah, I mean, let's try and change this, just so it actually changes. So right now, if we go not false or false, well, this will now be true, because, yeah, not false is true, so true or false is going to be true. Right, and then if, yeah, whereas, yeah, I mean, I guess here it's also going to be the same, actually, because, well, this will also be false. Right, but if we make this true, yeah, I mean, okay, that's still going to be true. Yeah, alright, but anyway, I mean, the key thing is that, you know, this is going to have higher precedence, right? So, you know, well, I would say most times you want to use brackets if you're using this not, just to be explicit about, you know, what's done first. Okay, so I think, I mean, that's all the kind of intro. So if we think how we can actually apply this, you know, using if statements, because, you know, just printing things out is not really very useful. You know, we want to actually go to different code blocks, depending on if certain conditions are true or false. So let's say here we're going to have a Boolean, can be attended, so whether they attended school, and then homework. Yeah, okay, so actually maybe the attend, so this can be a real, so this can be a percentage, right, and then the homework can be a Boolean for whether they did or didn't do their homework. So let's just say here, right, let's go declare, actually let's call it attendance, right, let's say real, let's also declare homework, and in fact actually let's say did homework. and right, well, whether they did homework, that's going to be a Boolean. Right, so the attendance, let's say this can be, yeah, maybe 0.9. So right, they had 90% attendance. Unless they did homework, right, this can just be true. So here then we can use an if statement to check. So let's check if they're kind of like let's say a good student. So if attendance is greater than or equal to, in fact, let's make this 95. So let's say if it's greater than or equal to 0.9, yeah, and did homework equals true. Right, so then we have the then. So this is saying, well, right, if this condition is true, right, then, and yeah, then we have a list of statements to execute. So here, let's just go output. Let's just say maybe A, right? So yeah, probably they're going to get an A grade. Right, then we can have an else. So else is, well, if they're not true. So here we could just go output, I don't know, like C or something. Right, so let's just try end if. However, I think eventually we will want more grades than this. But yeah, let's just see if this works. Okay, so here you see output A, because again their attendance is 95, right? So attendance greater than or equal to 0.9. This is true, right? Then we're checking and. So both this condition, right, and this condition both have to be true. And here, well, right, did homework is true. So here this is, well, true equals true, right? So yeah, they're both going to be true. Now of course, like if we say did homework is false, right, and then just run that again, well, now it's going to say C, because yeah, this one is true, but this one is going to be false. Likewise, of course, if we make this say like 85, right, well, 85, right, that's also going to say C. However, let's try to add another grade so we can have a C, and then maybe we can have just kind of like a fail, or yeah, like failure. So for someone that has really low attendance. So let's say here then. So then we can go if. And the thing with pseudocode is it doesn't. If you're familiar with other programming languages, most languages you can have an if, right, then an else if. Whereas yes, pseudocode doesn't actually support else ifs. You need to have a nested if. So that's going to be an if, and then yeah, inside, well, either inside this if here. Or probably inside this else block, right, you can then have another if statement, and then inside this if statement you can have another if statement. So here, let's say if attendance is, let's do the same. So greater than or equal to 0.9, and then here let's say or. So this will be if one of them is true, but of course not both of them are true. Right, so did homework equals true. And the reason the reason it won't go here if both of them are true is because, well, if both of them are true, it would have gone here, right? It would have done this output A, so it would have never gone inside this else statement. Because yeah, it's going to find that the first condition that's true, and then it's going to go inside here. It's not then going to check the rest, right? Where it is, yeah, it's not going to go inside this. It's not going to go inside this else part. Right, so anyway, let's go then. Right, then we'll go end if. And here, yeah, maybe this can be B, because I guess, well, they've got, well, either they've got a good attendance, or they did their homework, but they didn't do both. So yeah, let's say B. Right, and then here we can then probably just have another else. So this will be neither, right? This will be if, if their attendance was low, and they didn't do homework. So yeah, if neither of them are true. And then I guess here then we can just get output. Yeah, I don't know, C or like U or something. Right, maybe they have to get lucky. So right, let's just try this. So let's think, right, here we say, well, this one is going to be false, but this one is going to be true. So this whole thing is going to be false. So that means it's going to go to this else part. Right, so this, well, 0.5 is greater than or equal to 0.9, right, that's going to be false. However, this part is going to be true, right, so here it should just output B. Yeah, which is what we can see. Now, of course, if we then go false like this, right, that's going to say U, because, well, here, well, of course, right, this is false, false, then it goes to the else part, again, right, false. So, well, false or false is going to be false. So that means it has to go to this else part here. Right, and then again, if we just have, say, 95, and let's go true, then of course here it should go back to this A. Yeah, okay. So again, if this is the first time you've looked at if statements, probably just try and type this out yourself. Try and play around with different values. I mean, you could also, like maybe for example, we could change this to score. So, and I mean, I think score can just be an integer, to be honest. So let's say here score can be 90. Right, let's make this score. Right, and let's actually remove this did homework. I guess we don't really need it. So what we want to say is, let's say if score is greater than, maybe greater than or equal to 90, this can be A star. Right, and then try to think how you can use this to go, maybe if score is greater than or equal to 80, output A. If it's greater than or equal to maybe 70 or 75, that can be B. And of course, so on for like C, D, E, F. So just try and get, a kind of long list of grades. Alright, but I'll skip that because, well, actually we do have that here, just as, this kind of example program. So you can use that to see the answer if you want. Right, okay, so let's try this where they're going to enter a password. So what we want to do is we're going to have a password pre-stored, and then we want to ask them to enter their password, and then we'll check if the password they entered is equal to the correct password. And we can also use the not, so this would say like access denied. So basically just a simple login. So let's go declare, let's say maybe correct password. And then here we also want the user input. So maybe let's say like user input. Right, these are both going to be strings. Right, let's say the correct password, maybe ABC123, something nice and simple. So here, if you remember, we can go output. Let's say please. Right, please enter your password. Right, and then here we can then just go input. And here the variable we want to store this in is going to be this user input. Right, and then then we can just have an if statement. So we can say if correct. Okay, well let's say if user input is equal to correct password. Right, then let's just say output. Let's go like login. Like login successful. I think that's how you spell successful. Maybe. Right, and then else we can just go login failed. And right, let's go end if, and let's just run this. Right, so first let's try with the correct password. So just ABC123. Login successful. Right, and then let's try I don't know, AB12. Okay, and then here it goes, login failed. Now we could kind of invert this logic. So rather than checking if it's equal, we could go not equal like this. And then of course, while this would be failed, this would be success. So we could change it like this, or we could also use the not. Although to be honest, I would recommend kind of not using the not like this, because I think that this is just quite confusing because we're checking user input equals correct password, then we're just notting it afterwards. Which to me that's going to get quite confusing, quite early. So I think it's better just to use equals, and then if you want to check if it's not equals, well then just use the not equals operator like this. Let's try again, check that works. So again, password ABC123, right, success. And then 123, right, that's going to be failed. Right, okay, let's try this one. So I would say probably pause the video and see if you can do this yourself. So if we want to check if a given year is a leap year, well, there's going to be these three conditions. So first, it has to be divisible by 4. Right, and then if it is divisible by 4, then we also check if it's divisible by 100. and if it's divisible by 100, then it also has to be divisible by 400 in order to be a valid leap year. So what that's saying is, well, if you have let's say, like, 2004, 2008, right, 2012, right, these are all going to be valid leap years. But the one we have to check is that if it's also divisible by 100. So let's say 2000. So 2000 is divisible by 100, right, and is also divisible by 400. So yeah, 2000 would be a leap year. But let's say if we have, well, 1900, right, 1900, well, this is divisible by 4. However, because it's also divisible by 100, we then need to check if it's divisible by 400. Now, in this case, 1900 is not going to be divisible by 400. So actually, right, this wouldn't be a leap year. So, I mean, this was something I was kind of surprised about because, well, I thought leap years were every 4 years, but it turns out that actually, right, some situations, yeah, even if it's divisible by 4, it's not going to be a leap year. And the reason for that is because, well, like, I mean, often we're told that a year is 365.25 days, but I think in reality it's like maybe 0.48 or something. So of course, because this is a little bit less than 0.25, yeah, they just have to kind of cancel some of these leap years. Right, so I mean this one's going to be a bit harder. So yeah, let's see if we can try this, or see if we can do it. Right, so let's say, I don't want to say year because, right, this is the name of a function. So let's just say, I don't know, like year to check or something. Right, so this year to check, this is going to be an integer. Right, let's try year to check, and we can say, yeah, I mean, right, let's try 2000. So if we think, well, the first condition we can check is if it's divisible by 4. Now, if we want to check if a number is divisible by something else, we can use mod. So for example, if we want to check if it's even or odd, because, right, this is a common thing we want to do, so we can check maybe 5 mod 2 equals 0. Now this is going to be false, right, because 5 mod 2 is going to be 1, right, there's a 1 remaining. So yeah, if this is false, then it means it's going to be odd. Whereas if we think, let's say 4 mod 2, well, this is going to be true, right, so it's going to be even. And of course, 2 mod 2 is going to be 0, right, 4 mod 2 is 0, 6 mod 2 is 0, right, etc. So yeah, like all the even numbers, well, it's going to be true. All the odd numbers, so like 7, yeah, it's going to be false. So likewise, if we want to check if it's divisible by 4, well, we just do mod 4 and check if it equals 0. So here, right, let's go if year to check mod by 4 and check if this equals 0. Right, so then we want to do this. So then we can check, right, if year to check, right, if year to check mod by 100. Yeah, okay. I mean, I think this is not really the best way to do it because it's going to get quite nested. Right, if it's mod 100, then we can have another if, and then we want to check if, okay, sorry, let's make that equal to 0. Right, then we'll go mod by 400, and we're also going to check if this is equal to 0. So in this case, right, this should be valid. So let's say output, and let's say year to check, and we'll just go and it is a leap year. Right, I'm just going to copy this. Right, and then I think I didn't mention it before, but when we have the if, well, we do need the end if just to kind of close it. So here, right, let's go end if. And in fact, let's also go else like this. So here, right, let's go is not a leap year. Because, for example, this could be like 1900. So 1900 is divisible by 4. 1900 is also divisible by 100. But right, 1900 is not going to be divisible by 400. So yeah, therefore it's going to go here. And to be honest, right, then we can just go else as well. Right, just copy that. So right, this is going to be, you know, honestly, right, this is not the best way to do it. But right, so this is going to be if it's, yeah, if it's not divisible by 100. Okay, so actually, right, this would be, it would be a leap year, because this would be like 2004. Right, then let's go end if for this one. Right, and then if year to check mod 4. Yeah, okay, right, then we can just go else. And then right here, well, this is going to be not a leap year. Okay, so, you know, this actually gets quite complex because, well, we've basically got kind of 3 levels of if statements. Yeah, so it's, you know, quite heavily nested. Now, to be honest, like we could do something like this. We could say, I mean, well, let's just run this, right, see if it works. Okay, so 2000 is a leap year, that's correct. Let's say 1900, so this should say false. Yeah, so not a leap year because, well, this check is going to fail. I mean, let's try 1600, right, this should be true again. Yeah, and then if we try, you know, 1604, yeah, that is a leap year, and then let's try 2023. Yeah, 2023 is not a leap year. Okay, so this is working. So in order to actually simplify this, to remove some of the nesting, we just have to look at the 2 conditions when this is true. So the first situation is, well, you know, here, right, if the year mod 100 equals 0, right, and if the year mod 400 also equals 0. So yeah, both of these if statements are true. And then, well, we see the next one, well, it's going to be here. So this is where, what if year to check mod 100 is not equal to 0, because yeah, that's when, well, we see this if, well, this if and this else, they're kind of, you know, the same, or at least, well, you know, the same level. So if this if fails, right, then the code is going to go to this else block. So yeah, basically we just need to add this here, or we need to add extra conditions to this initial if statement. So right, first, I mean, let's just check these 2. So, well, we want to check if this condition is true, then it's going to be like, well, and either this or this one. So let's actually put this in brackets, and the reason for that is, let's say we have something like maybe A and B or C. Now, the way this works, I mean, we can think about precedence. So this is the same as doing, say, A multiplied by B plus C. Obviously, right, the multiplication has a higher precedence, right, or a higher priority. So this will happen first. Whereas, yeah, the or, right, this has a lower priority. So, I mean, what this is doing then, of course, I mean, this is the same as just doing this, right, by putting it inside brackets. Now, what we want to do is, well, we want this B or C to happen. Or, well, effectively, we want it to be A, and then and, well, either B or C. Yeah, so, you know, I mean, this should kind of happen by itself, basically. So yeah, we can just put that in brackets. So right, so here then the first one is years to check mod by 100, and we want to check that that equals to 0. And then because, well, that's going to go inside, kind of is going to go here, right, but then this also has to be true. So then we need another and, it's going to be years to check mod by, right, mod by 400 is equal to 0. And actually, like for the same reason, because we've got an and then, well, an or, let's put that there, right, and then we can just go or like this. Now, this one technically doesn't need to be in brackets, but I think it's just good practice to use brackets. You know, it's better to have too many brackets than not enough, because, yeah, I mean, too many brackets is you know, not going to cause any problems. Right, so here then the condition, well, we want to check if this years to mod 100 is not equal to 0, because if it's not equal to 0, well, then, like I said, it's going to go to this else statement here. So, right, years to check mod by 100 is not equal to 0. And I mean, this should be fine. So if we just tidy this up a bit, right, let's go here. Okay, and yeah, let's just test this. So here then 1900, well this should say is not a leap year. So yeah, just ignore this. This was broken earlier. Okay, so yeah, here we go. 1900 is not a leap year. Now if we try, I mean, let's try 2000. So this should say it is a leap year. Yeah, and of course something like 2004, right? That is a leap year. And then maybe like 2023. Yeah, this is not a leap year. Because I have actually seen questions like that where maybe they would give you a format like this, where you just have loads of, you know, like and, ors, and then you have to convert this into the nested version, or they might give you the nested version and ask you to like remove the nesting, so just to, you know, convert it all in one line like this, or kind of one condition. Alright, so actually then, I mean, for the if statements, I think, yeah, hopefully you should be sort of more confident now. Again, you know, just have some practice, and I mean, if we look here, right, you can also go to the challenges. There's a lot of practice questions here which you can have a go at, and of course, yeah, look through the demo programs too. So now then, if we just talk about the last thing, so case. So I mean, if statements are good, but the problem is if we have say many different conditions, well, I mean, we could have, you know, so many different if statements. Like for example, let's go here. So here we're checking what if score is, you know, greater than 80, then right A star, right then A, B, C, D, E. So yeah, of course, I mean, you know, this gets quite complex. You know, it's a lot to type out. So yeah, maybe we would prefer not to have this much nesting. So in order to actually solve that, we can use a case statement. So first, let's actually declare, and we'll just call it age, right? Because this will be the age of a person. Right, let's go integer, and let's say the age can be, I don't know, say 22. So what we then do is we say case, then we say of, right? Then we need the variable that we're checking, or, you know, the value that we're checking. So here it's going to be this age. So yeah, this is checking, well, the value, right, of this. Right, then I'm just going to say end case just so I don't forget. And then here, this is where we can have our conditions. So there's actually 3 types of conditions we can use. So the first is just going to be separated with a comma. So let's try, for example, 0, 1. Or yeah, maybe 0, like, yeah, so like this. So here we'll just say output. And let's just say, yeah, like, I know you are a baby or something. So what this is saying is, well, if the age is either 0, 1 or 2, right, then it's going to say like you are a baby. Now, of course, I mean, here they are just like sequential, but we could also have something like, you know, I don't know, like 85. So you just have some random values. And to be honest, you know, you could even try like a string, right? Although, I mean, in this case, well, age is an integer, so yeah, this is a bit pointless. Right, so yeah, let's leave that. Right, then let's say we want child. So, right, for the child, let's say we want 3, right, then we can use 2. So let's say probably until 12. And then we'll just go output, yeah, you are a child. So, of course, here, well, this is just going to get the range, right, so the range from 3 to 12. Right, and then if we try the next one, let's say maybe 13 to... yeah, I guess, well, I mean, sort of 18, 19. Let's say 18. Right, so you are a teenager. Right, okay, then let's go for adult. So let's go 19 to, I mean, let's say like 99. Let's say output. Right, let's say you are an adult. Right, and then let's say for 100 we want a special case. So if it's 100, we'll just have this on its own. Right, let's go output. So you are a centenarian. Yeah, I've got no idea how to spell this really. Maybe something like this, right? So they're 100 years old. Now, then we can also have the otherwise. So the otherwise is equivalent to the else, right, in an if statement. So otherwise means, well, if none of these are true, right, then we just go here. Right, so again, let's go, yeah, output, and I guess we can just say, I mean, the thing with this, right, is this could be -1, right, or it could be sort of over, over 100, but I don't know, I mean, let's say like invalid age or yeah, I mean, let's say invalid age, and then what we'll have is, let's say, I don't know, like 100 to 200. In fact, let's make that 101. And then, I don't know, let's say like over 100, and we'll just say amazing or something. Alright, so yeah, we can just try this. So if we say 22, well, 22 should say you are an adult. Yeah, okay. Okay, right, I'm just looking at that. So the reason it said that, and I guess, yeah, I'm just blind. Basically, it said that because, well, here this is just a string, right? So, like it says, well, did you forget to use an operator? I mean, often this happens if you forget to use like a plus or something, because you could have something like maybe 4, 4, right? And it's like, well, you forgot to use the plus in between here. In this case, I guess I've just forgot to use the output. Alright, that should work. Okay, let's try again. Yeah, okay, so here we get no errors, and it's going to say you are an adult. Now let's see, I mean, of course, I mean, we can try all of them. Let's try 1. So yeah, you are a baby. I mean, I think 3 to 12 we don't need to try. Let's try 100. Yeah, so you are a centenarian. Let's say like 101. Yeah, over 100, and let's say, for example, like -1. Okay, so yeah, we see -1 is going to be invalid, and let's also try, sort of 999, right? So something bigger than 200, and yeah, okay, we see this also says invalid. So, all right, let's try just one more example again, just using the case. So let's just delete everything just so we can practice, the whole syntax again. So here what we want to do, we just want a case statement. So while we can ask the user for input, the user will then type in a character, and then we'll then tell the user, well, if it's uppercase, lowercase, let's also say number, right, symbol, or or let's say other as well. So yeah, we'll just tell the user kind of what type of character they typed in. So right, let's go declare, let's say, I mean, just like user input, I guess. This can be char. Right, then let's say output, so please enter a character. Right, then we'll go input, and again we say, well, this should be stored in the user input variable. Right, and then here let's go case of, and then we say user input, so this is the variable we're checking. Again, I'm just going to say end case, just so I don't forget. So here, if we think, in fact, sorry, this shouldn't be user input, this should be ASCII of user input. So yeah, if you remember ASCII, it takes a character, right, then it returns the ASCII code, or possibly the Unicode, if it goes over like sort of 256 or bigger. So right, if you remember, so you need to think, well, what is the range of uppercase? So if you remember, that's going to be 65, and then it's going to go to 90. So let's go output, and we'll just say maybe user input. Right, then we'll concatenate, and we'll go is maybe an uppercase. Well, yeah, well, let's say is uppercase. Right, and then I'm just going to copy this because basically it's going to be the same. So here we want to think, well, what's the range for lowercase? So yeah, hopefully you can remember. Right, so that's going to be 97 until 122. Right, then let's just go lowercase. Right, let's try, yeah, is a number. So again, if you remember, well, 0 is going to be 48. So here this is 48, and it's going to go to 57. Yeah, I think 57 is 9. Okay, and then let's say a symbol. I mean, a symbol is going to be harder, to be honest. because yeah, you would need to know the kind of range of symbols. So this is actually the problem with a case. Like, we can't, for example, symbol, we can't check, if it's, I don't know, if it's in the range, say like 100, or so, I don't know, if it's in the range like maybe 123 until 130, maybe there's some symbols. I think also like before 48, right, these are also some symbols. I think also after 90, there's also some symbols here. So, you would need to do like many different case statements for that. So I think this one we can probably just ignore. And then, this other, right, then we can just use otherwise. So actually let's copy this. And let's just say what is non-alphanumeric. Right, and let's kind of give the user a prompt, so we'll tell them to enter a alphanumeric character. Right, so an alphanumeric. Okay, so I think this should work. So let's say they try like T. So T is uppercase. Let's try small t. Alright, small t is lowercase. Let's try 5. 5 is a number. Actually, let me try 9. So 9 should be 57. Yep. Alright, and then if we just try, say, like the @ symbol, and then so @ is non-alphanumeric. Right, so again, guys, I think that's everything for today. So, again, just make sure you're confident with all of this, right? So, I think arithmetic operators, these first 4 are okay. Exponentiation, I think if it's a positive, or if it's a kind of like, sort of whole and positive power, then it's okay, right? Like power of 2, power of 3. But remember, if we want, say, the square root, well, the square root we can do, let's say like, this. Right, and then the square root we can do, 1 divided by 2, obviously cube root 1 divided by 3, right, quad, 1 divided by 4. Div, right, this is going to be the integer division, so kind of like doing the divide and then just, kind of ignoring the decimal, sort of ignoring the real part, basically. Or you can say this is like how many, if you have the pizza, this is like how many whole slices of pizza would people be getting. Mod, right, modulus or remainder. This is going to be, how many are remaining after the division. So like how many bits of pizza would be left over. Right, comparison, I think this is the only one people sometimes forget. So the not equals, let's just make that a bit bigger. The not equals is going to be, just the less than and then the greater than sign. I think these other ones people can remember. The only thing I do see sometimes people doing is they would go something like this, where they say equals and then, greater than. But remember, it's always this way. So you have the greater than or less than sign comes first, then it goes equals. Because, you think how you read it, you say greater than or equal to, right, or less than or equal to. So the greater than and less than comes first. So and or not, hopefully these are okay, not just inverts it. And then just for if, just remember you're not allowed an else if. So this can actually be confusing to some people, if they've programmed in a different language, where, they can just have like else if, else if, else if, maybe like 10 else ifs. Here you're going to have nested ifs. So if you're doing that with many else ifs, you'd have to have like sort of 10 if statements like nested inside each other, which can actually get, quite complex, quite confusing. And then I guess to solve some of these problems, you can use a case where, again, case can have a range. But of course you can also do this using an if statement, right? You say, like if ASCII of user input is greater than or equal to 65, and less than or equal to 90. Which, if you wanted to do that, because I do see some people doing this slightly wrong. So let's go declare, let's say maybe, like ASCII value. Right, this is going to be an integer. This is, we're just going to assign this AF's, the ASCII of the user input. So some people will do, and in fact, let's just delete this. Some people will try something like this. So they'll say, well, is it greater than or equal to 65? And then they go and less than or equal to 90. Now, I mean, if we try and run that, let's just try end if. So let's go uppercase. Probably it will give us some sort of like parse error here. Yeah, okay, unexpected token. So, I mean, what that's saying is we also need to write again like this. So we can't just say, right, if ASCII is greater than or equal to 65 and less than or equal to 90. You know, we also need the variable as well here. Yeah, and then if we do that, again, let's just try T. And then, yeah, here it says uppercase. And I suppose, again, I'm getting this error because it's saying, well, yeah, this code is just not doing anything. Alright guys, so yeah, I think that should be finished for this class. Now, if you've got any questions, of course, you know, leave them in the comments, right, send me an email. And yeah, hopefully see you in the next video.